Our next speaker, José William. He is a member of Rails Core, a rock star. We showed the video last year to prove it. He is the founder of Plataforma Tech, a software consultancy in Brazil, and the author of the Crafting Rails Applications, quote from the Pragmatics, right? Pragmatic Programmers. So please welcome him.
Hello, can everyone hear me? Great, so I hope everyone is having a great time so far. I hope we continue having a great time during this talk. So today I'll talk about writing our own programming language to understand Ruby better. This talk is not about creating a programming language, it's more motivational talk to get everyone inspired to create new stuff. And some of you probably know me, I hope, because of the open source projects I involved, both me and my company, Plataforma. And I participate in Rails. We have projects like Device that are very popular in the Rails community. And one of my latest projects is called Elixir, which is basically simple object orientation and charming syntax on top of their language machine. This talk today is not about Elixir. This talk today is about Ruby. But I just want to talk like 5 minutes about Elixir, so we can see like what was my motivation to create a new programming language, right? One of those motivations was their Erlang virtual machine. The Erlang virtual machine was built by Ericsson, which is a telecommunication company, and they have very specific requirements because they are building stuff like telephone switches. And the requirements are that you have a lot of calls happening at the same time, so you need to be able to handle concurrency very well. You need to be able to literally have like 100% uptime. You don't have like phone calls for operators saying, hey, you're going to be from maintenance mode from 0 a.m. to 3 a.m., right? This kind of stuff doesn't happen. So they built a virtual machine that was based on concurrent processes. Those processes, they are not operating system processes. They are like an abstraction on top of threads. And the only way for those processes to communicate is through messages, right? So it's message-based. And they have things like how to code swap. So you don't need to bring your system down to put new code there, right? You can update your code while everything is running. And it runs with low memory because you don't have like 2 gigabytes for telephone switches and kind of stuff, right? And a virtual machine is not enough if you don't have a programming language. So the Erlang virtual machine comes with the Erlang language, which is like very small and quick to learn. It's a functional programming language, but for those who are in programming Erlang, even like for us with Ruby, syntax gets a lot in our way because like it's weird, honestly, and it has no object orientation. Object orientation, the word per se, like does not mean anything because nobody was able to come up with a consensus of what is object orientation. But when I'm working with Erlang, I feel like it's missing some kind of abstractions to make me feel more productive, right? To make me design software better. So it's missing something, right? And Elixir is an attempt to solve those two issues. It's an attempt to add a little bit of method dispatching, polymorphism on top of the Erlang virtual machine, and add a charming syntax, which in this case is extremely inspired by Ruby syntax, right? So this was like one of the reasons to create Elixir, right? And the second reason is because I love Ruby, and I think everyone here loves Ruby. But you may ask, which kind of love is this? And I would say that it's tender love. Right? And it's a tender love because I think that it's our responsibility as a community to go out and try new things, right? I don't recommend you to do this in your marriage, but for our community and programming language, we have to go out, try new programming language, try different paradigms. Even if you're working with Rails, I recommend you to go out, try other frameworks, and learn different ideas, and try to see how you can make Ruby better, Rails better, or whatever tool you're using better by trying out different things, right? So this is what this talk is about. It's like, what have I learned? What can I propose to Ruby after creating my programming language? After trying Erlang and trying a different virtual machine with a lot of different concepts, right? So this talk is going to be divided in two parts. The first one is things I learned about Ruby, and the second one is called What If, which is basically what if we had this feature in Ruby? What if this particular thing was different in Ruby, right? So let's get started. First, things I learned about Ruby. I will start talking about the syntax. And in order to talk about the syntax, I want us to go to understand a little bit how programming language, the whole compiler is, or interpreter is structured. And imagine that we have this thing, we have puts high, right? And this needs to become some code, needs to become bytecode or native code, needs to be converted to something that the machine is going to understand. And the way it works is that it passes through several steps. Now usually the first one is called Lexer, which is also called tokenizer. And what is going to happen here is like, if it's a tokenizer, it's going to convert this into a series of tokens, right? And those tokens, for example, could look like this. It could be an identifier. So we're saying like we have one token, which is an identifier. This identifier is success. And the second one is a string high, right? And the tokenizer is doing like very basic things. It can just recognize stuff like symbols, strings, numbers. It cannot do a lot of work, right? But that's fine. It's our first step. And then the second step is usually the parser. And the parser is usually generated by a grammar, which has a set of rules saying like, if I have an identifier token followed by a string token, this means that this is actually a method call, right? And then we start to create something that looks like a tree, right? That's why we have like abstract syntax tree or syntax tree and this kind of stuff. So here we're basically saying that what that means that we are calling the method puts, passing string high as argument, right? So this method call is passing just one argument. And then we have a lot of steps. One of those steps is called semantic analysis, which I want to focus here today. But this example is very simple, so semantic analysis is not really anything special. We are going to get there. And this is finally going to begin into other steps that is going to generate bytecode for virtual machine or native code, and then this can finally be executed. Right? So what I want to focus today is on the semantic analysis step. And the reason why I want to focus here is because when we generate a parser, we generate it using context-free grammars. So it means that it cannot do a lot of work, and it can potentially generate ambiguity. So we have to do semantic analysis to decide if something, for example, is a variable or a method call, right? We are going to see some examples. And Ruby relies a lot on the semantic analysis to behave the way we see Ruby behaving today. So one of the things that Ruby does in the semantic analysis step is provide us with a very flexible grammar. And here's an example, right, that everyone's familiar. We can define a method foo that's going to return 1, and I can call this method with implicit or explicit self, right? So I can say foo is going to return 1. I can say self.foo is also going to return 1. And what I can also do is that I can define a variable called foo, set it to 2, and now if I have just foo, it's going to return the variable. And if I have self.foo, it's going to return 1. Right? So basically what this means is that when Ruby sees foo, it needs to decide, it's ambiguous, right? It needs to decide if that's actually returning a variable or it should do a method call. Okay? And the way it works if we pass it through our chain is that we have a foo, and then it's going to pass through the Lexer. The Lexer is going to say, hey, this is an identifier foo because the Lexer is not very smart to understand all of stuff. And it's going to give you the parser. The parser, again, it's not exactly sure what foo is, so it's basically going to say this is also an identifier foo. And then it's going to the semantic analysis step that finally needs to decide, right? What is foo? Okay? And then, for us to see how it works, that imagine that you have a method bar, and you are setting the variable foo to 1, and then returning foo. If we generate the tree, if we use the Lexer plus parser, it's going to return, we can say it's going to return something like this. So I have a method bar that's made by the following expressions. It's made by an assign, which I'm assigning the integer 1 to foo, and is returning an identifier foo, right? But we know that the Lexer plus parser, they cannot say what is an identifier. So the semantic analyze step will come and say, hey, actually, this identifier is a variable. And the way it knows that this is a variable is because the semantic analysis is going to receive this whole tree, and every time it sees something like identifier foo, it's going to look back in the tree and see if at some moment we did assign foo. If at some moment we did assign foo, it means that we should return the variable foo, and we should not do the method call foo, right? And this is something that it seems simple, but it's actually not that simple to implement. And I felt like very happy when I was able to implement those exactly the same semantics in Elixir, right? So in Elixir, we can do like the same kind of stuff, and it was like a huge learning step for me because I had to think about how this should work. We need to consider several scenarios, like when you are starting a new scope and this kind of stuff. So it is challenging. It's not easy, right? So point one here is that Ruby is doing a lot of work there for us, right, to make we feel expressive. And I was happy until I found like more Ruby-specific semantics that I want to show you. So I imagine this example here. I removed the syntax highlighting here on purpose. So we have a method bar that receives an argument, and we are doing our dot class, right? And then I'm calling this method bar, parsing regular expression, and this code is going to return the class regular expression, right? But if I do this code now is going to return 0, right? Because what we are doing here is that we're saying bar, which is 0 divided by 1 divided by 2, right? So what it means is that when Ruby parser, Ruby Lexer, and parser, they see this kind of stuff, they cannot actually be sure that this is a method call, receive a regular expression. It may be the operator to do the division, right, between variables. And I tried to implement this in Elixir, but I tried, and I could not implement it. I could not make it work, and then I eventually gave up and said, okay, I can try to implement that later. I'll work on other things. And this is, again, the main point here is not that I was a failure to implement that. If even Phoenix is watching the talk, it's probably laugh at me, but the point here is that Ruby, the Ruby developers, Matt, they are putting a lot of effort in the language to make us feel productive, right? So we don't need to every time, imagine if your components had to look like that, right? Self-dot, self-dot, self-dot param, self-dot render, self-dot flash. It does not look good, right? We can just skip all that stuff. We don't need to use special syntax for regular expression, right? We can just remove all this crap, right? So this is one of the things I learned about the syntax, right? It requires a lot of effort to get it straight, and I think that Ruby got it properly the huge majority of the cases, unlike other languages like JavaScript. Okay, so before I go to the next session, I try to add some trivia here, and for the trivia, this one particularly, I would like your participation, right? So imagine we have an array with 3 elements, and I want to call array.length plus 1. Who thinks this is going to return 4? Please raise your hands. Nobody thinks it's going to return 4? Just 4 hands, no math? So this is going to return 4, gentlemen. And ladies. Right? This is going to return 4. Okay. Now I want you to think about this case. Array.length space plus 1. Who thinks this is going to return 4? Okay, some of you, this is actually not going to return 4. What is going to happen here is an argument error because Ruby is going to consider that you're calling the length method passing plus 1 as argument, right? So again, again, Ruby needs to do this kind of stuff because it wants to allow us to call methods without params, right? And it's hard to implement, again, because in general, the Ruby Lexer, parser, they ignore white space. White space does not matter, except some specific cases like this, right? So now everyone, and if I do this array.length space plus space 1, is it going to return 4? Yes. Yes! Okay, I like it. Yeah, it's going to return 4. Okay, another very short trivia. And what about this case? Is the first one a block or a hash? Who think it is a block? Please raise your hands. Yeah, it's going to be a block, right? And the second one is going to be a hash. I hope. Someone can check. I added that last minute because Tenderlove requested it, so I haven't checked it. But I think it's correct. Okay. So that was about the syntax. So we have like those a lot of those small cases that most of the time it works transparently for us because Ruby developers they were able to get it properly, so we don't have to worry about it. It works like almost transparently in our minds, right? So the second thing I want to talk about Ruby is the object model. So So when I was implementing Elixir, I wanted to implement something that resembles an object model. And in order to do that, I need to really understand how the Ruby object models work. And I had to answer a question, which is where methods are stored in Ruby, right? So where are we storing methods in Ruby? And the most tricky case is, in this case, we're defining an object, and we are defining a method specific to that object and calling it, right? So I was thinking about it, and I was trying to figure this out. And I'm going to tell you the answer first, because it's going to make it easier for us to reason about it, right? So in Ruby, methods are stored in modules, right? So every time you're storing you're creating a method, it's being stored in a module. When we think about the entity, right, that's being stored, I'm not talking about a hash table or something like that that's internal to the implementation. I'm talking about conceptually, okay? And let's prove this, right? So the first example, we are going to create a module greeter, define the method greet there, and then we can include this module in the class person. And we can create an instance and call this method, and that's going to work. And here is very clear that the method is being stored in a module, okay? And so far, good. The second example is we are going to define the method straight in the class, right? And we'll be able to create again an instance and call the method. And now it's the method seems to be stored in a class, right? But what is happening here is that if you do person is a module, it's going to return true because the superclass of class is a module, right? So far, all good, right? So methods are indeed stored as a module so far because class, the superclass of class is a module, right? And then if we consider the first example, object equals object.new, and we are defining what we call singleton method, and call object.greet, what is happening here, right? Where is the method being stored, right? And then let's do a little bit of investigation. We can say object.class.ancestors is going to return all the ancestors for that class. And if we ask if any of those ancestors define the method greet, is going to return false, right? Which makes sense because that method greet is going to be defined for that specific object, okay? So where is that method being stored after all? It's being stored in something we call singleton class. So if we do object.singleton class.method define greet, it's going to return true. And if a singleton class is a class, it means that a singleton class is a module, right? So that was important for me to study and realize, and I think I like to share. I think it's to share it because I think it's very interesting. And it was again when creating another programming language or studying another programming language, it made me reason about it, right? Even though it may be useless in 99% of the cases. Okay, so with this, I want to end the session, the things I learned about Ruby. But before I go to the next part, more trivial. Why once says, he didn't say if this exactly works, is in the Potion readme, something like that, but he said, creating your own programming language is fun, lovely, if you can keep it under 10,000 lines of code. And another trivia is, Ruby sparse Y is more than 10,000 lines of code, right? So just the Ruby's grammar is more, Ruby grammar and related to chains more than 10,000 lines of code. Yehuda has a theory that I haven't validated yet, that maybe Ruby sparse.i has more lines of code than pm.c. We need to verify that. Okay, so let's move to the next part. What if? So here I'm going to ask you again to raise your hands at some times because I'm going to give you ideas of what could be different in Ruby, what we could change. And I want you to say if that's a good idea or not, if I'm crazy, and this kind of stuff, right? And the first, I'll start with the most polemic one. But I want you to think about it, and it is, what if we did not have blocks, right? So what if we did not have blocks in Ruby? And I'm going to explain it, right? First I need to say that I love blocks, the Thunder love way. And we use a lot of blocks in this kind of stuff, right? We say file open Logabaruco, and I want to write to that file. And this is extremely convenient because what Ruby is doing here is that they are opening the file, giving us control of the file in the block, and then we can do whatever we want. And then after we do whatever we need to do, it's going to close the file automatically for us, right? So we don't need to worry about this kind of stuff. And so this works fine. And my proposal, now I want everyone to look carefully, and I propose that instead of doing this, we are going to do this. Everyone see the difference? So instead of doing this, we are going to do this, right? And the proposal is basically that instead of having do and end to mean something very specific, which is a block, I want to use do and end as the syntax to define lambdas, right? So what is happening here is that I'm not, so the Ruby way is that I'm calling open, passing one argument and a block. And what is happening here is that I'm calling open, passing two arguments. The first one is a string, and the second one is a lambda, right? This is going to resemble a lot more how we do stuff in JavaScript, right? We are keeping pass functions around more easily, right? And that's the idea here. So here, the do end, again, it's returning a lambda, as if it were the lambda keyword, right? So we are basically removing blocks in favor of having a nicer syntax for lambdas, right? In fact, if you had to put parentheses here, we would put parentheses around all that, right? And the advantage is that we would be able to write code, which I think, sorry?
Will you still be able to pass another block into it outside?
Yes, you would be able to pass another block, yes. So I'm going to move to more examples. So this, I think every person starting with Ruby tried to write this at some point, right? And it doesn't work in Ruby because when you're passing a lambda, you need to use the ampersand, right? But in this case, again, it will resemble a lot like we do stuff in JavaScript, that we could just define the lambda there, and you're simply passing it as second argument, right? So we don't have this special thing called block, right? We are making lambdas more easy to pass around, okay? So if we have no blocks, there's no need for you, there's no need for ampersand block, and passing more than one block around is more natural, right? Because you're simply calling a function with 2, 3, 4 arguments or something like that. Okay, so who actually thinks this is a good idea? Okay, I'm happy. So this is how I implement in Elixir, right? So in Elixir, there is this thing called block do end. You're basically creating lambdas. Okay, let's go. What if we had array and hash comprehension? So a lot of languages, they have comprehension. I think Python has. JavaScript, they want to add it to the next specification. And comprehension is basically this. We are going to define an array, and then in this example, for each x in n, we want to multiply x per 2. That's going to return 2, 4, 6, 8. It's basically as calling the method map in the array. And so what is the advantage here, right? The advantage is that comprehensions, they have two things. One of them is called generator, which is x in n. And the second one is called filter, which we can filter values that we want to pass the generator and this kind of stuff, right? So here I'm basically mixing up select and map together, and it's going to return just those filtered elements, right? And then you can consider that we can make this more powerful with the generator API is actually based on some specific method that we call back in the object, right? So it allows us to do a lot of crazy stuff, right? And we can even, like, we're not limited to have one generator and one filter. We can add, for example, two generators, right? You can do x in n, y in n, right? And we can define a filter in function of those two, and that's going to do the calculus for us again, right? So this basically, you don't have to write select and map. It tries to make this a little bit more expressive. Right? And then if we express it, and if you want to write, instead of array comprehensions, if you want hash comprehensions, you can do stuff like that. Just change the brackets to curly brackets, and it's going to return a hash as argument with the key and values, right? So, who likes this? You think more people like it? I'm sorry to disappoint you, but I suggested this to Max, and he said that he doesn't like it. Okay. And since you're talking about hashes, another proposal is, the most popular one is, what if our hashes were more like JSON, right? So, Ruby 1.9 already takes the first step and allows us to have the syntax, right? And what I'm proposing here is that we'll be able to use quotes, right? We'll be able to do this, right? And, okay, and I said more like JSON because I think it's not going to properly map to JSON because there are things like string encoding and escaping of characters, but it's going to be a little bit closer, right? So this one is the most popular, the shortest one. So, and Hen thinks this is a good idea. Everyone is wrong. Starting from here to here. Okay, so this is a good idea. Even Max agreed this is a good idea. This is actually the second time I've given this talk. I gave it at Heroku. And Max was there, and right after I finished the talk, someone submitted a ticket through RubyCore issues tracker. And Max said, I'm okay with it as long as the semantics is exactly this one. Right, so quoting here in the 1.9 syntax, not going to return a string, it's still going to return a symbol. At first I thought it's weird, but it actually is a good idea because it's consistent, right? If you're using the 1.9 syntax, always the keys are always going to be symbols, and you can basically consider the quotes as an escaping mechanism, right? Because you cannot have A minus B as a symbol, you need to quote. Right? So I've been meaning to so the ticket is open. Max already said what is the semantics he would like on this, but I think nobody implemented it yet. I've been meaning to do that, but if anyone wants to go first, you don't need to worry about me, you can do it. So, the other suggestion is, what if we had better pattern matching, right? So again, pattern matching is one of those loosely defined terms. A lot of languages implement and associate different things with pattern matching. And in Ruby, we can do like a little bit of pattern matching. It's basically, so one of the things in pattern matching is to be able to destructure arrays or similar structures, right? And in Ruby, we can do this kind of stuff, right? So I'm basically getting the first two elements of the array and assigning the rest to zip, right? And basically, if you're improving those semantics, we would maybe be able to do this kind of stuff. Right? We would be able to destructure an array inside another array, right? So I honestly don't see where I will use this, but that's basically what the pattern matching semantics define, right? And another thing, so one is pattern matching associated with destructuring stuff, and the second part of pattern matching is usually assertions, right? And the way it would work here is that you are trying to assign 1 and 2 to X at the same time, and it's going to say, this cannot possibly work, right? How can you want to assign X to 1 and 2 at the same time, right? And this is going to raise an error, right? So we are basically here asserting somehow that the first two elements of the array needs to be equal, right? And we could take these assertion semantics to the next level by, sorry, I lost the connection. So here, if we try to assign X and X with the same values, it's going to work. And we could basically take this to the next level by allowing a prefix operator that says, I don't want the value of X to change. So I define X to 1. And then next, I'm saying, I don't want the value of X to change. I don't want to assign a new thing, right? And it's going to raise an error because I'm basically comparing 1 to 3, and that obviously does not work, right? And then it's going to raise an error, but if I'm trying to assign 1 to X, which is 1, it's going to work. So this is another part of pattern matching, which is a way to do assertions, right? And again, as a structuring, I don't see me using this in several scenarios. I think that this is particularly not adding a lot, right? But again, this is just part of what we can do with pattern matching, right? One of the other scenarios we could use pattern matching would be in method dispatch. So in Rails, for example, we have a method form for, and the method implementation usually goes something like this. If I have an object, and the object is a hash, I'm going to do something. If the object is an array, I'm going to do something different. And if none of those, I'm going to do something completely different, right? And we could use pattern matching as a way to specify a method with different clauses. Don't worry about the syntax here. Just worry about the feature, right? And here, I would be able to break form for in 3 different with same method clauses, right? So I would say like, if the record is a hash, I'm going to call this part. If the record is an array, I'm going to call this part. And if it's none of these, I'm going to call this as part, right? And the way it works is that I would first try the first definition. So if it's a hash, I'm going to enter the first one. But if it's not a hash, I'm going to try the next, and that's how it goes, right? So method pattern matching, I think it would be a nice advantage because it's going to be better to maintain. We can break into smaller sections the code. It would be better to document because we can document the hash specific behavior under the form for hash, right? But there's something bad there because if we add this kind of stuff to Ruby, it's basically demoting loop typing, right? Basically, instead of checking if it's a hash or if it is an array, we should somehow say, give me an element that I can use in form for, right? We should use method dispatching and do loop typing. Okay, so this is not going to help us a lot, but again, we can consider more stuff, right? So programming languages as Haskell and Go implement interfaces. So maybe we could try to mix these all together. We could mix pattern matching and interfaces as a way to say, hey, here for form for, I need an object that implements this interface, right? I need an object that has a method toolkit there. I need an object that has a persistent method, right? And then we could ensure somehow that this kind of stuff is happening, right? So we would mix pattern matching and interface and this kind of stuff. Do you have a question, sir? Oh, okay, just freaking out. So basically, again, so one of the lessons here also is that designing a programming language, it's hard. Maybe you should go shopping, but that's exactly it, right? Maybe when you start adding stuff like method missing, it's hard to implement interfaces in your language, right? So designing a programming language, you have to do a series of trade-offs, right? When you implement one thing, maybe you are giving up 10 other things, right? That could make your programming language worse or better. We cannot foresee all the things that is going to come up, right? But so maybe not just one person freaking out, but several people. But who think this is a good idea? Who think this is a good idea? Okay. Who thinks just pattern match is a good idea? These are your hands. Okay. And who thinks interface is a good idea? A declarative way to say this object needs to implement this interface. Okay. So see that everyone that likes you likes the other. So good. So again, let's move on. Another feature. What if we had, this is actually, forget the implicit part, but what if this had partial application, right? And underscore has special semantics in many functional programming languages, right? And the way it works is that underscore is basically dev loop, so basically everything assigned to underscore is discarded, right? It's always new. You can use a way to think it's a way to say, I don't care about this stuff, right? And we end up using this a lot with pattern matching because you can say, I'm actually just interested in X, Y, 1, and Z. I don't care about that other part, right? So, so underscore would be basically a way to send stuff to that loop, right? And then some programming language build on top of that and try to add more specific semantic to underscore, which is instead of doing, for example, stuff like names.each and putex, what we can do is that we can do stuff like this, right? We can say that I'm calling the method puts, but I don't know yet what is the argument, right? I don't know yet what is the argument that I'm passing here. So this puts underscore is going to generate a lambda, right? And then we can make it pass a block and pass it to the function, right? So basically what I'm saying here is that puts underscore is going to automatically generate a lambda for us, and then we can do this kind of stuff, right? It's basically a way that, this is what they're getting, right? This is partial application in many functional programming languages. They're saying, I don't want to apply the argument now, so please generate a lambda that is going to apply this argument lazily here, right? So it's very convenient, for example, when we have an array and we want to print our names, right, and this kind of stuff. So who thinks this is a good idea? Who would like partial applications? No, a lot of people, nice. So you're getting close to the end.
How do you make the difference between calling two arguments or calling your next that?
So what is the difference between the two?
How do you decide to call your function with one argument or two arguments?
Can you repeat the question?
Yeah, I'll repeat the question. But I didn't understand the question properly, sorry. So what is the difference?
Why not do the second example? I could interpret that response to question mark x, comma y. How can I know that you have to call x first?
So basically, so his question like how in the response to example we know how we need to call x first, right? Did I get it correct? So basically it's order specific, right? Maybe we could allow to do okay, maybe it's order specific, right? So the first underscore is going to be the first argument, and the second underscore is going to be the second argument. And here is implementation detail, right? The x and y. It actually doesn't matter. You just need to, oh, the example is wrong. Sorry. Okay, I see. I'm sorry about that, but we can fix it. It will basically be this. Sorry. This makes more sense, I hope. So we're saying respond to and then expecting two arguments, right? And then we have x and y, which is basically where the underscore are being methods. Alright, so I'm sorry. Okay, so, right.
Can I ask a question?
There's more questions.
Well, over here. What happens if you end up using something like that inside a lambda? Is there going to be confusion as to which the underscore refers to?
So if I use the underscore inside another lambda,
Yes.
so it's just going to generate a lambda inside another lambda, right? So, okay. Okay, so basically, we could like, if this, I think we could, if it seems that a lot of people agree, I think we could maybe try to submit this to the Ruby core, or I can try to write a blog post and try to have some discussion around this, where it would be more expressive, right? But I'm going to move on to the other features, but you can ping me next. So this kind of stuff, most of the things I am talking here, they are implemented in Elixir, right? So if you have doubts, if you have questions on how these things work, you can, for example, try Elixir and see how those things are working there, okay? Okay, so that's it. So this is the feature. It's called partial application. We can basically delay the call of a method by creating a lambda. Right? And the last proposal is what if we define a syntax tree, right? And okay, one supporter, that's already great. So, so when I was at the beginning of the talk, I was giving an example about how the method bar resembles a tree and this kind of stuff. I created this thing, right? This thing came from my head because Ruby does not have an specification for this, right? Ruby does not expose how things are being handled internally, okay? And this proposal it's about the different Ruby implementers to maybe gather together and see if we can expose this kind of stuff, right? If you can expose the tree because it's important mainly because it would allow us to do crazy stuff. And that's a good idea because it would allow us to experiment. It's going to expose something more internal to the Ruby virtual machine. We can already do crazy stuff in Ruby, that's why Ruby is great. But if we have something, a tree that's shared among all the specifications, we are guaranteeing that our crazy experiments is going to run in different virtual machines, right? So that's great. So I'm going to show an example of the crazy experiments. But again, we're going to see that the experiment is really crazy. But again, the point here is that it's going to allow us to be even more creative, right? To experiment on top of Ruby. And the example is like this. Imagine we have class foo, and I have a method bar. And what I'm doing here is that I'm saying memorize def bar and whatever is the implementation of bar, right? And the way it works is that what is happening here is that I am actually defining the method bar, and the method bar is going to return a method object and pass this method object to memorize, right? So our memorize implementation is going to be something like this. It's going to be memoized, it's going to receive a method, and if the tree is exposed, the memorize method could get this tree, manipulate, do a lot of crazy stuff with it, and then say, hey, I want to redefine this method, right? Why this is a bad idea? Because your back traces are going to go crazy, for example, right? Debugger, give up on that, probably not going to work, right? But again, the point is that it would even be able for people to create subsets or supersets of Ruby and try different stuff with that, right? Which is basically, so for example, by having the tree, we would be able to do which every JavaScript developer is doing right now, which is like writing a translator or stuff like that. So you can create, they are creating supersets of JavaScript, names that translate JavaScript, and doing this kind of stuff with tree would allow everyone to do that and run different virtual machines. Okay, so wrapping up, those are the things I wanted to share about Ruby with you. The things maybe it would be interesting to have in Ruby. You already gave good feedback. What would be cool to add to Ruby? So maybe we should start these discussions around that. And again, the point of my talk is to get everyone here to try out something new. Everyone here should try out a new programming language. Should maybe try to implement a programming language on their own. It's going to be hard. Regardless if you have the whole, if you have a CS degree, it's going to be hard, but it's extremely rewarding, right? And everyone is going to be able to learn different stuff. Everyone is going to be able to have new ideas, and maybe next year can even be like one of you sharing crazy stuff, crazy shit that we could add to Ruby, right? And I would be very happy to see this kind of talk here, right? So again, so maybe you can try out Elixir. It's not going to get too far away because the syntax is very similar to Ruby. But again, it's different new because we don't have mutability. It uses the whole Erlang message-based thing, so you can learn new stuff with that. And if you want to create a new programming language and you don't have the whole technical background, you can probably start with this book, How to Create Your Own Freaking Awesome Programming Language. They are using Ruby to create a programming language there, so that's going to help you because you're probably familiar with Ruby and how Ruby works. And I would say that it was very nice because the group organizers, then they put another 2 talks about another programming language, which is the Go language, and a talk by Constantine, which is about implementing your own language on top of Rubinius, or implementing Smalltalk on top of Rubinius. So the next 2 talks, I hope you're all, I'm sure that you're going to learn a lot of great things, right? So thank you very much, and I'm open up for questions.